Look at this beautiful tree pattern on my screen. It looks quite beautiful as well as quite realistic. We have three colors being used here: brown for the branches, green for the, let's say, the last leg, last level, and finally a small little dot to kind of convey a fruit or a flower, whichever way you want to imagine this. Now compare this to what we developed in the class, and the difference is this. Basically, this looks quite barren, but then this looks really colorful and attractive. We'll see in this video how we can go from here to, let's say, here. In a step-by-step manner. As always, we are enhancing our fractals and recursion project from the YByte Python curriculum, available at www.ybyte.in. Let's get started with enhancing, let's say, our project to convert our tree into something this beautiful. Now, there are really, few points to be understood. First and foremost, the recursive logic between these two projects has not changed. And that is kind of evident when I look at, for example, the tree here, or let's say the tree over here. So clearly the recursive logic has not been changed. But what has changed is that we are going to make three important, let's say, updates to our code. First one, the thickness of the branch depends on what level we are looking at. Now, remember that the level goes like in a descending order. So, for example, 8, 7, 6, 5, and so on and so forth. Basically, for the larger number levels, we use a bigger thickness. Next, you notice that for the level 1, we make the thickness small, but we also change the color to green, whereas everything else here was brown. And finally, we make a small little dot to, on level 1. So let's just see how we can do. So here's my branch code. Now I'm just using 20 degrees as the angle, and that's what I've done in the other one as well. But basically, like I said, a few things I'm going to do. First thing first, I'm going to make the pen size a function of the level. Now that is not hard at all. In fact, I can just go and say, look, when I'm drawing something, before I start drawing anything, I will just set the pen size to the level itself. Now, why this works is because remember, as we go through the recursive process, the level keeps decreasing, and hence the thickness is highest here and keeps on becoming smaller and smaller. Now remember, I want to set the color of the pen also as a function of the level that I'm in. In fact, as we just saw, everything is, let's say, brown here except these last two. But remember, these last two are level equals to 1. So I can just go and put a code here. If level is equal to, say, 1, well, let's say t dot color is equal to, say, green. Now, obviously, this is your choice. You can be creative here as well. Else, let's say I just go and say t dot color is let's say brown, right? So just kind of indicates a tree branch. Finally, remember I had this little dot. Now the dot can be obtained by the dot function, but then the dot must happen in level 1 once I have moved forward, let's say, till this point. So that's basically this code. Yeah, now remember, in every level, basically the idea is that we're moving forward. Now in level 1, once I'm moving forward, at this point is where I would want to put a dot. So I just go and say, look, if level is equal to 1, I will just go and say t dot color, let's say red, and I just put a dot, say, for for the thickness of 5. Remember, dot is like putting a like a dot literally on the screen. Now this is really all I need. We are going to test this now. But as part of my code itself, I am aligning my turtle to the right position. I am clearing the screen. So when I run this piece of code now, so when I now run my code, my turtle is in the right orientation at the right location, just waiting to be commanded. You notice this heading is upwards because I've set the heading to 90 as part of the code. I just give this command branch, let's say 108, and I expect to see my tree as, basically a colorful tree, a realistic colorful tree. When I run this, however, something very interesting happens. You notice that it does look like the color of the leaves is green, but very soon it gets overwritten and the entire tree starts to appear brown and then red. See it very carefully. Every leaf is being drawn in green color, but then eventually we notice that it's getting, it's basically getting overwritten. Now this itself looks beautiful, but this is not what we are intending. So let's analyze in our code what is it happening so that we can fix this, because this also gives us a understanding of the dynamics of this recursion. Basically, while this code runs, let's just go back to our code. Remember, what we are doing is that, if level is 1, which is I'm like basically I'm at the last level, I just go and say, look, once I move forward, I will set the color to red and I'll draw this dot. However, remember, as part of my recursion, I must bring the turtle back, and I do bring the turtle back. At that point, the color has become red. That's why if you see carefully, I draw it in the green color, but because of this command, the color in fact gets overwritten in the reverse path. So, the entire tree then starts looking like everything on the outer edge is in fact red. I mean, like I said, this also looks beautiful, but not what we were intending. So how do I fix this? Well, very simple. Basically, when I'm bringing my turtle back, which happens from this command, I can just go and say, well, look, t dot pen up. So please do not write anything when you are being brought back. And at the end of this, I can go and say t dot pen down. So with this, basically, my turtle on the way back won't write anything, but subsequent to that, it will be perfectly fine. So now when I run this piece of code, you notice that it's exactly what I had intended. There's a green branch, and then there are those red dots. That's because, my turtle is not overriding whatever it had done earlier with the new color. And this looks really, really beautiful. Exactly what we were intending to do. Um, Now, clearly, you notice that this process takes a long time. While it's good to look at because we understand recursion, really you can see it happening here. But sometimes after we are used to this and we want to build denser trees, we may want to run the tracer commands, and we'll see this in just a moment. We will in fact build a bigger tree with exactly this setting. However, we will, do it with the tracer 0 so that we can just update quickly and see the final outcome. So we'll do that once this gets over. Um, but for now, just it's fun to look at this anyway, right? And it's really, like I said, you understand how recursion is actually flowing through this. All right, so we are done now. I can just say t dot clear. Let me, send my turtle down a little bit. So t dot say go to maybe 0 and minus say minus 200. So it goes down just a little bit more because we are going to draw something more. I'm going to say t dot clear and say ts is equal to t dot screen. And then I'm going to say, well, look, ts dot tracer say 0. And when I now run this piece of code, which is basically just this, but let's just run it a little longer to say, let's say depth of 12. When you notice it looks pretty cool. In fact, when I now ts dot update, that will complete the whole drawing. It looks really nice. I can see glimpses of red, glimpses of, let's say, green and so on and so forth. This tree actually looks quite beautiful. I hope this has been interesting to you. Like I said, very creative exercise. There's logic, which by the way of recursion, but there's also ample room to make it beautiful as we are seeing here. In general, building an activity to a basic level and then thinking how we can enhance it is a good way to learn programming because this way our learning is incremental, systematic, as well as fun. Look at our website www.ybyte.in because that is how we learn Python programming at Ybyte. Take care. Thank you so much. Bye bye.